You know that specific sinking feeling of dread when you look at a server log file.
Oh, yeah.
You've spent weeks, maybe months, building this incredible, complex application on top of a large language model.
hmm
It's writing poetry, it's summarizing Shakespeare, it is absolutely brilliant. And then you try to connect it to a database and the whole thing just explodes.
And usually it explodes because the AI decided to be, well, polite.
Exactly. It's the, hello, here's the JSON you asked for problem.
Right.
You ask the model for raw data, and it gives you a conversational intro. And your backend code, which is expecting, a curly bracket to start a JSON object, gets the word hello instead and just throws a fatal error.
It's a classic clash of cultures. I mean, on one side, you have software engineering. It's rigid, it's deterministic, it's binary.
Right.
A thing is either true or false, a number is an integer or a float. And then on the other side, you've got generative AI, which is probabilistic, creative, and notoriously messy.
So today, our mission is to fix that clash. We're doing a deep dive into a stack of resources focused on mastering LangChain output parsers. And the central figure in these materials is a persona they call the code architect.
Which is a pretty fitting title, I think, because what we're discussing today isn't just about writing code. It's about designing a structure that can actually withstand all that chaos.
The mission statement here is pretty bold. It's to unlock structured data. We're going to figure out how to take those wild, unpredictable AI responses and force them, polite chit-chat, and all into predictable formats, like JSON objects that our code can actually use.
We're essentially training the artist to fill out a spreadsheet.
I love that image. Okay, let's unpack this. The source material kicks off with a scenario that I think just grounds this problem perfectly.
The customer service chatbot.
The customer service chatbot.
Right.
This is basically the hello world of enterprise AI at this point.
Right. But think about the difference between a chatbot that just talks and one that actually does things. If you're just chatting, text is fine. But the moment that bot needs to look up an order status, the game changes completely.
So imagine you're the developer. You need this bot to get specific things from the user to run a query. You need an order number, maybe a delivery date, and let's say an email address.
Simple enough on a human level. If I say to you, hey, I'm checking on order 555 for next Tuesday, you know exactly what the data points are. You instinctively separate the data from the sentence.
But the LLM, it processes that and might come back with the user's asking about order number 555.
And that right there is the failure point, because your API, the code that actually talks to the shipping database, it takes an integer. It takes 5555.
Right.
It does not take the string the user's asking about. You can't perform a database query on a sentence.
It's like trying to put a paragraph of text into a calculator. It just returns syntax error.
Precisely. The source highlights that an LLM's default mode is continuation. It wants to continue the conversation, but software needs extraction. And those are two very, very different objectives.
So, enter the hero of our story, the output parser. Now, usually when we hear parser encoding, we think of something that just, reads a file like a CSV. But in the context of LangChain, this seems to be doing something a lot more active.
It is much more active. Think of the output parser as a diplomat stationed between two warring nations.
Okay.
On one side, you have the creative, messy LLM. On the other, the strict, uptight application code. The parser's job is to negotiate. It takes the text output, strips away the preamble, deletes the here's your data, and hands over the pure, clean JSON.
So it's the thing that deletes the pleasantries and just hands over the object.
Exactly. But it's not just about deleting words, it's about enforcement. And that brings us to the most critical concept in this entire stack of research. The schema.
The schema.
Yeah.
Okay, this sounds like we're getting into the architecture side of things.
We are. The source uses the analogy of a blueprint. You can't just tell the AI, give me JSON. That is way too vague. You have to define the shape of that JSON. And the tool the code architect points us to, which, if you're a Python developer, you probably already know, is Pydantic.
Pydantic is massive right now. It feels like it's eating the Python ecosystem.
For good reason. In standard Python, you can be pretty loose with data types. You can have a variable that starts as a number and then becomes a word.
Yeah.
But Pydantic enforces strict typing. It allows you to say, this variable is an integer, and it will always be an integer.
Okay, let's make this real. The guide gives us a concrete example of a person class. Walk us through that.
Sure. So let's say your application needs to create a profile for a person based on their chat history. You don't just want a blob of text. You define a person object using Pydantic. You tell it, I need a name field, and that must be a string of text. And I need an age field, and that must be an integer.
So if the AI tries to write the word 25 spelled out,
A standard JSON parser would just pass that string through, and your database would crash later when it tried to do math on the word 25. Pydantic steps in, it tries to validate it. It says, wait, I need an integer.
but the source material goes a step further with validation, right?
Yeah.
It isn't just about the type of data, it's about the logic of the data.
Exactly. This is where you get into that mastering territory from the title. You can set roles. You can
Right.
tell your schema the age field must be an integer, but it also must be between 0 and 120.
Oh, that's smart, because otherwise the AI might hallucinate and say someone is like 500 years old.
Or -5. By defining that range in the schema, you are catching errors before they ever even touch your database. It prevents the system from ingesting garbage data just because the AI had a hiccup.
I like that distinction. It's not just formatting, it's gatekeeping.
It is data integrity.
So we have our blueprint. We know what we want. But the sources mention there isn't just one type of parser. There are a few flavors, depending on what you're trying to do.
Right. LangChain comes with batters included. The sources specifically mention built-in translators for the most common needs. The most common one is obviously the JSON parser.
Sort of workhorse.
But the list parser is surprisingly useful. Think about a prompt like, give me 5 ideas for a blog post.
You don't want a paragraph. You want a comma-separated list or an array so you can display them as bullet points.
Exactly. If you get a list, you can iterate over it in your code. For idea and ideas, print this. If you get a paragraph, you have to write all this complex code to chop it up using periods or new lines, which is just prone to breaking.
But the source material asks a really important question. What happens when you have weird requirements? What if you aren't using standard web formats?
And that is where custom output parsers come in.
The example given is XML. Now, XML isn't as trendy as JSON these days,
Not at all.
but a lot of legacy systems still run on it.
It is the ghost of enterprise software past, but it's still everywhere. Let's say you're building an AI tool that needs to talk to a server from 2005. That server doesn't speak JSON. It only speaks a very specific, ugly dialect of XML.
So you can't just ask the LLM for
It
XML.
could, but it might invent its own tags. It might give you user when you need process user ID. With a custom output parser, you can enforce that specific tag structure.
Ah.
You're essentially teaching the parser the specific dialect of your legacy system.
So you're basically training the bridge to speak a specific language.
That is a great way to put it. You're ensuring that no matter how the user phrases their request or how the AI generates the content, the output fits that rigid, old-school slot. It turns the AI into a universal adapter for your tech stack.
Reliability is the key word here. But, and there is always a but with AI, things do go wrong.
They do.
The code architect, our guide here, points out a reality check. Even with a blueprint, even with a schema, LMs sometimes hallucinate. Or they just mess up the syntax. They might forget a closing bracket on a JSON object.
And in traditional coding, a missing bracket is a death sentence. The program throws an error and just stops.
So what do we do? Do we just cross our fingers and hope?
No, we have strategies. The source material outlines 2 very specific mechanisms for error handling. The first one is pure genius in its simplicity, the retry mechanism.
How does that actually work? Is it just running the prompt again and hoping for a better result?
It's a bit smarter than that, and this is a key insight. When the output parser detects an error, say a missing bracket, it doesn't just crash, it captures that error message from the Python compiler.
Okay.
Then it sends the prompt back to the LLM along with the error message.
Wait, so it tells the AI, you made a syntax error and here's the error log.
Exactly. It says, here's what you wrote, here's why it failed, now do it again.
That's like a teacher handing back a paper and saying, check your work.
Yes. And LLMs are surprisingly good at fixing their own mistakes when you point them out. Usually, on the second try, the model corrects the syntax and returns valid data. It creates a self-correcting loop.
That feels like a huge leap toward reliability.
Yeah.
But what if it doesn't? What if the user input is just total gibberish? Like you ask for an order number and the user types, I like turtles.
You can retry that 10 times. You're never getting an integer out of it.
So you're stuck in a loop.
And that is where the second strategy comes in, the default response.
The failsafe.
This is all about application stability. If parsing fails consistently, instead of letting the app crash, the parser returns a predefined valid structure. It might be empty fields or a flag that says error, but it's structured.
So the rest of your code can handle it gracefully. It sees order number, null, and knows to ask the user again rather than just exploding with a fatal error.
Precisely. It keeps the user experience smooth even when the brain behind it is, confused. If you don't have a default response, you really don't have a production-ready app.
Okay, moving on. The sources take us into what they call advanced parsing logic. This is where we leave the simple stuff behind.
This is the level up portion. We're talking about complex nested data structures.
And the example here shifts from a chatbot to e-commerce.
Right. Imagine you are using an AI to scrape product details from an API or maybe just a block of text. You have a product. Inside that product, you have specs. Inside specs, you have dimensions. And inside dimensions, you have width and height.
It's Russian nesting dolls of data.
And the challenge is, sometimes fields are missing, sometimes the data types are wrong. Let's say you're extracting the width. The source text might say 10 inches, or 10 inches, or just 10.
And if your database expects an integer, 10 inches is a string. It breaks.
Correct. Now, a basic parser might just reject 10 inches, but advanced custom logic allows the parser to fix the data.
Wait, so the parser is actually fixing the data itself?
Yes. It's not just checking it, it's cleaning it. You can write logic inside the parser using regular expressions or simple string manipulation. It sees 10 inches, strips the word inches, converts the 10 to an integer, and then places it in the correct field.
That is incredibly powerful. The parser is acting like a janitor. It's cleaning up the mess before it lets the data inside.
That is a great analogy. It's not just a bouncer checking ID, it's cleaning up the data to make sure it fits the dress code. This is technically known as type coercion, but really it's just about making sure the data is usable.
The source material really doubles down on this idea of validation, specifically bringing up the Pydantic output parser again. We touched on Pydantic earlier, but let's dive a little deeper into this specific tool. Why is the Pydantic output parser getting its own spotlight here?
Because it combines everything we've just talked about into one automated package. But there's a hidden feature here that I think most people miss. It involves something called prompt injection.
Prompt injection. That usually sounds like a security vulnerability.
In this case, it's a feature. When you use the Pydantic output parser, LangChain actually modifies the prompt you send to the AI. It appends a specific section of instructions.
What kind of instructions?
It takes your Pydantic schema, that blueprint, and automatically writes out instructions that say, by the way, your output must match this specific JSON schema. And it injects that into the system prompt before the AI even sees your question.
Oh, so it's doing the prompt engineering for you.
Exactly. You don't have to manually write, please give me JSON in this format. The parser injects the schema definition directly. It gives the LLM the answers to the test before the test even starts.
That is a key insight. You're not just hoping the AI knows what to do. The tool is explicitly instructing it based on your code.
And then once the output comes back, the parser handles the validation, the type coercion, and the error handling we talked about. It catches the issues before they can break any downstream code.
The source gives a final example of extracting book information to illustrate this. Title must be a string. Author must be a string.
Simple, right? But imagine the AI returns the author as a list of strings because there are two authors, Neil Gaiman and Terry Pratchett.
A strict string parser might break because it sees a list instead of a string.
Right, but the Pydantic output parser forces consistency. If your model defines authors as a list star, the parser will try to force the AI's output into that list format. If the AI returns a single string, the parser might fail. Or if you've configured it well, it might coerce that single string into a list containing just one item.
It seems like the big takeaway here is moving from trust to verification.
That is a perfect way to summarize it. When we started with LLMs, the vibe was very much, wow, look what it can write. It was magic. But you can't build a business on magic.
Right.
You need reliability. You need to know that if you ask for a price, you get a decimal number, not a soliloquy about the economy.
And output parsers are the tool that turns that magic into mechanics.
They ensure data integrity, they provide type safety, they turn the probability of an LLM into the certainty of software engineering.
It's fascinating because it feels like we're taming the beast. We're taking this wild neural network energy and putting it in a suit and tie.
We are. And if we connect this to the bigger picture, it changes what we can build. Suddenly, an LLM isn't just a chatbot that answers questions. It becomes a component in a larger machine. It can drive a database. It can control a robotic process. It can execute code.
Because we can trust the output.
Because we can trust the structure of the output. The content might still be weird. The AI might still say something odd, but the structure will be sound. The pipe won't burst.
So to recap our journey today, we started with the chaos of raw text. The frustration of getting conversational paragraphs when we wanted data. We introduced the output parser as the bridge, or the diplomat.
We talked about schemas and blueprints using Pydantic to tell the AI exactly what we want. We covered the different types from simple JSON parsers to custom XML builds for legacy systems.
And importantly, we looked at what happens when things break, using retry mechanisms to create a feedback loop and default responses to keep the ship afloat.
And finally, we looked at how advanced logic can actually clean and fix data on the fly, making these systems incredibly robust.
It really is a comprehensive toolkit for anyone trying to build real applications with this technology.
It is the prerequisite for building agents. If you want an AI agent to go out and do work for you, it needs to speak the language of systems, not the language of people.
So here's a thought to leave you with. The source material emphasizes mastering these parsers. It talks about unlocking structured data.
Right.
If we can now force these creative, hallucinating, unpredictable LLMs to adhere to strict logic, validation rules, and schemas, if we can force them to behave exactly like a database, are we approaching a point where the line between generative AI and just traditional software disappears entirely?
That is the question. At what point does the AI part just become another function call in your code? If it's deterministic, is it still AI?
Something to mull over as you stare at your own messy data logs this week.
Indeed.
That's it for this deep dive. Go unlock some structured data.
And master those parsers.
I'll see you next time.